Here I have a Delta44 and a Maya44 running in parallel from one IQ Plus. And you can see there are no glitches. First I will look at the suitable gain setting. So I make the step size 1 decibel and then increase the level until there is a problem. Here is a problem, and in the Delta44, and as you can see there is 3 decibels of headroom in the Delta44, so saturation must happen in either in the input of the Maya44 or in the hardware. So I go to the Maya44, to the Maya44 gain control. It's here, and turn down the gain. And then I will reduce the level, and it is clever to go to a frequency closer to the center, because here you can see there is a lot of distortion, so this level is actually too high. This could be a suitable maximum signal to get out from the IQ Plus. In the Delta44 I have to press Z to clear the detector. So we have 6.9 decibels of headroom, means I can go to consumer mode without saturating. And now saturation happens very close to the same level in both in both the IQ Plus and in the Delta44. Then I do the same with the Maya44, means I want the same headroom here, so I press A and then bring up the gain sliders. Like that perhaps, and the other one. Oh, that was too far. Once more. It's difficult to move just a single pixel. 1.13, so I want 1 pixel up here. Something like that. Well, this is precision good enough for the purpose. And now you can see there are glitches occasionally in both sound cards. This is Windows 10. It is now using this video recording software, and then I see the glitches. When I turn off, it's called S recorder. When I switch it off, there are no glitches. I will try to fix that by setting higher priority in LinkRF. Now I have set the priority for the two LinkRF instances to 2. And you can see there is a heavy load on the CPU. And actually the Maya44 doesn't work as well as it did before. But if I look here on processes, we can see that background processes system interrupts 20% of the CPU. Task Manager 2%. Well, I close it. And I don't need this one either. So these glitches disappear when I switch off the video recording. But I would like to see the sound cards work also while recording what happens on the screen, so I will do some more tests on the settings. I have now asked LinkRF for twice as large buffers. It seems to be a little bit better, but it's not okay. The driver I have installed for Delta44 is this one, 5.10.005057. And it's this one, and I installed it like this using the troubleshoot compatibility, and allowed Windows to decide what Windows thought would be the good compatibility setting. And here is the release notes that accompany that driver. So I'm now closing down things I don't need. The Maya44 has the 1.0.0 driver, the oldest driver. That's the one I found most reliable before. And I don't need this program. I went through the back door when changing priority. Let's see. This looks odd. I close this. Some unused instance of LinkRF. 2. Okay. So now when I don't move anything around on the screen, just allow the two LinkRF instances to run, you can see that the Delta44 runs without glitches, while the Maya44 has glitches, although not very frequently. It happens occasionally only. It seems reasonable to change the latency. It's 256 samples, that's not very much. So I have to exit X, and then I can probably change latency. Let's say now it's 1024, and then go back here, B, and it seems that solved the problem. So now two instances are running with two different 4-channel sound cards at 96 kHz, and they run without glitches, and it's with a pretty good margin if I stop the video recording. So now I will go on and looking at the calibration, and I can compare these two sound cards. They have a little bit different characteristics. I have placed the signal 750 Hz above the center frequency. So if I step down by 1.5 kHz, you can see that the signal and the mirror image, they change places. So this is a good starting point for the calibration. And I restore the normal gain for the waterfall, that's one, to put the two systems on equal footings. I have removed the calibration files from previous setups, and I have then to first do the mirror image calibration, which is I have to get focus to one of the LinkRFs, X, and calibrate, and A, and then the same for the other instance of LinkRF, X, calibrate, and A. And it talks about overload, so I reduce the signal level by 2 decibels and set the frequency stepping to 1.5 kHz. And then change the number of segments, which is now 32, and I increase that plus to 64, and the same here, and that fits to the 1.5 kHz stepping that I'm going to do. So now I'll do the stepping, and I will come back when it's finished. All the segments are green. I press U to compute the correction function, U, and you can see it's different between the two sound cards. the slope of the phase is much larger in the Maya44. Maybe there is a time difference between I and Q, and that would give a phase that changes with frequency. Anyway, I will accept this, so I press enter and then S to save the contents of RAM, and X and go back to the processing screen. And the same here, enter and save, and X and D. And here we now have the two systems with calibration for the mirror image. And I can step the frequency a little bit, go up here, and the mirror image is very small in both sound cards. But here you can see fairly strong spurs. They are not the mirrors, they are the audio overtones. The audio frequency is now about 10 kilohertz. So 20 kilohertz from the center you have audio overtones, and both above and below the center. And the third overtone and the fourth overtone is much weaker. So this is typical for direct conversion receivers. I have connected a pulse generator, and I will calibrate the frequency response. And that's B. And then here also B. And this pulse repetition frequency is far too high. I make the pulses much stronger. This is too strong for the calibration, but it's good to see the shape of the pulses. And here you can see how far away the tail of the pulse goes. It's about 1/3 of the screen. So a suitable pulse repetition frequency could be something like this. So there is a bit of noise floor between the pulses, and I insert some attenuation to make sure I'm not overloading anything, like that, and then press enter, and here also. "5,000 pulses is more than enough." So I press U, and the same here, and when you look at these, the difference is very small. I didn't mention, but the big difference on the previous screen is that the time delay is, the time shift between the channels is essentially 0 in the Delta44, but it's quite a bit different from 0 in the Maya44. I accept these curves as they are. It means the ERFC, fairly steep fall off at the edges. So why? And then save this, and then here Y, and save the calibration. and I allow it to collect for a little time. And as you can see, the time shift between the channels is 0.0005 in the Delta44, but it's 0.0213 in the Maya44, which means that although it is compensated for, it's not quite completely compensated for. So I allow this thing to run for a while again. Uh, 5,000 pulses is enough to have a good statistical averaging of the pulse shape. So I go here on the Delta44. The time difference between channels is 0.0004 samples. So I press U to compute the correction, and then on the Maya44 I can see that the time shift between the samples is 0.258 samples. That is a substantial shift that has to be corrected. I press U, and in both cases I will accept the suggested white curve, what I want to have. It's fairly steep. It's the ERFC function. So Y to accept here, and Y to accept here. And as you can see, for the Delta44, the time difference between channels has degraded. It's now 0.002 samples, while for the Maya44 it's 0.01. I don't know why it isn't better. Maybe I made a mistake somewhere, but anyway, I will accept these calibration curves that have been obtained. So I press S, and then X, X, and D. And the same here. I press S to save, and then X, X, and D. And I reduce the pulse level a little bit because pulses were very strong. And I can enable the second time function oscilloscope by pressing the little O in the high resolution graph here, and the same for the Maya44. And then I reduce the gain of the second time function a little bit. It's now 0.0019. So I do it the same here. 0.0019. So this is the interference pulse. It is saturated. You can see the white waterfall, and the main spectrum is red, and that's not acceptable. It means the noise is too strong. I attenuate it one more like this. Now the noise pulses are not so strong anymore, So I can use the smart blanker, press here, and on the Maya44 I press here, and it doesn't work at all on the Maya44, so I press X and B, X and V. This time it works. And there is a difference. It works better on the Delta44. On the Maya44, the sound card has to start with the same time shift that was used during the calibration. I have started the calibration once more, and you can see the amplitude, the magenta, is very flat because the system is already calibrated. So now I am trying to make an improved calibration. And you can see the time shift between the channels, 0.002 or 0.01 in the two sound cards. And the number of pulses averaged is already rather big, 6,700, so that's enough. I want to compute a new correction, that's U, and here U. And as you can see, the edges have become sharper. I don't want that, so I press F to reduce the steepness on the edges, and also here F. So now they are similar, and I press Y to accept this, and then S to save, and here Y to accept, and S to save. So now I have saved these new improved calibration functions, and the time shift now evaluates as 0.004 on the Maya44 and 0.001 on the Delta44. So I will be happy with this, I hope. Pressing X, X and D, and here X, X and D, and I have to reduce the pulse level because the main spectrum is now red. I do that by going into the parameter settings menu, that's X and P, and I set the first FFT amplitude. It was 2000, I make it 500. And the same here, X, P, and I make it 500. And as you can see, the main spectrum is still red, so I attenuate the pulses a little bit. They are very strong. The smart blanker is enabled. I disable it, and I disable it here. So you can see the pulses are fairly strong. Looking at the S meter, and I don't want adaptive polarization. Let's put it like this, and the same here. So this is the pulse problem. I make the repetition frequency higher, like that, and then enable the smart blanker. And on the Maya44, the smart blanker. And as you can see, it is a little bit different because it occasionally becomes red, meaning the pulses are too strong. I attenuate them a couple of dB only, like that. And to see anything, I make the level of the waterfall different. And now I disconnect the noise source, the pulse generator. And as you can see, the difference between the two systems is very small. So it works for the Maya44 and for the Delta44. The next step of the calibration procedure, removal of the center discontinuity, is going to change the calibration function. So I save the functions I have now produced, make directory save, and copy the frequency response calibration here. And then, of course, the same for the Maya44. Because the center discontinuity removal function has a lot of options, and maybe I want to demonstrate the consequence of different choices. So it's the DSP SSB core. That's the frequency response calibration. And I want to copy it in here. And then I go to the center discontinuity removal function, X and C and C. And I make the center limit, which is now 562 hertz. I make it, let's say, 3 kilohertz from C. And then the same here, X, C, C, and L, and 3000, and continue. And then look at what these things look like. Plus, 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 plus. Plus, 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 plus. The difference is very small, and this is nothing to discuss. I press just A, and then on the other screen A. Here there is obviously a difference. On the Delta44, I press R because I want the curve from the blue line up to the edge to be near 0. On the Maya44, it's uncritical. I can move it a little bit, but it doesn't make much difference. But you can see the near the edge, the red curve starts earlier in the Maya44. I press minus to see better 3 times, and here minus 3 times. There is some difference, and this is the phase function on the audio side that is different. Yes, the differences should be only for the audio side, so this makes sense. I press A, and then A here. And I don't think anything matters. Oh. And I want to change the center limit, that's L, I make it 3 kilohertz. And continue with current values. I press A. A. Sorry, continue, that's C. And plus, 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 plus to see better. And then on the Maya44, the same thing. X, calibrate, C, and L, and 3000, and C, and plus, plus, plus. These things look very similar, so I just press A here, and then A here. And these functions look very similar also. So I just press A, and then on the other screen A. And there isn't much difference. A, A, and A, and A. So these are the calibration functions, and the important thing is the phase. So I magnify by pressing plus 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. The The phase functions are much steeper in the Maya44, but the ugly thing at the center is smaller. So I save S XXD, and then here S and XXD. As it happens, the Maya44 didn't start with the appropriate time shift, so I make X and then again B, and now it was correct. And whether this is better or worse than before is not trivial to say. I disconnect the noise source, the pulse generator, and I think what I did was a degradation of performance. It's only about halfway between the center and the edge that the pulse subtraction done by the clever blanker is really good. I can compare the sound cards. The signal generator is set to minus 21 dBm. So I have calibrated the S meters to show minus 21 dBm. As you can see here, minus 21, and the other one, the Maya, it's minus 20.82. That's because I couldn't set the gain control more accurate. There is a 0.2 dB error I made. So I switch off the signal generator like that, and then look for the noise floor. Here we are. And I look where the noise floor is reasonably low. It's out here. Let's say 144-120. And the hardware is controlled by the Delta44, so I set the Maya44 for the same frequency, which just affects the scale, not the hardware. And now you can see that there is a difference. The noise floor in the Delta44 is minus 128, and in the Maya44 it is minus 123, or maybe minus 124. Anyway, the difference is 5 decibels. This means that the noise figure at the input of the IQ Plus is 5 dB better with the Delta44 than with the Maya44. Now this Delta44 card is modified, so it's a little bit better than the original design. You can read about that on my homepage. But even an unmodified Delta44 is a bit better than the Maya44. While producing this video, I have discovered something interesting. Both sound cards are now running with the noise blanker, the smart noise blanker, enabled. They have been calibrated similarly. And you can see if I disconnect the noise source, that's the pulse generator, that the S meter shows that the difference is very small, a dB or less. And this is a really strong source of noise. As you can see, if I switch off the blanker here, sorry, it is about 30 decibels of noise. So I put the blanker back. The interesting phenomenon, which is new to me, I don't know the reason for it, is obvious if I press X and then B. Look at the Delta44 window. For about 1 centimeter on my screen, performance is better, and then it degrades a little bit. Once again, X, B. So that is not desirable. If I look at the Maya44 here, I press X and B. Now it came in the wrong time shift between channels, so I try once more. Oh, once more. And it's the same. About 1 centimeter, something happens, and mostly near the edges of the spectrum. Probably there is some decision taken in the smart blanker routine after waiting for a little while, based on the signal levels, noise levels, pulse levels, whatever, to set some threshold in a way that is not optimum. I will look into this, but I think this video has interesting enough information, so I will just upload it before fixing this particular problem.